Hello everyone. In this video, we will learn about the theory behind the decision tree algorithm. Okay, this is a supervised machine learning technique that is used for the purpose of classification and regression. Okay, and these are all the steps which is involved in building the decision tree. So the first step is like we have to begin with the entire data set as the root node of the tree, and we need to select a feature, okay, which is the best feature to split the data set. So this is typically done by calculating the metric such as either you can make use of entropy, information gain, or Gini impurity. Okay. And then we will select one of the feature that is able to give the maximum value for the information gain. So we need to split the data set. Once the feature is chosen, we need to split the data set into the subset based upon the possible values of the feature. Okay, so say for example, if there is a feature called as like what is the temperature for a particular day. So if temperature for the day, if it takes the possible values such as it is cloudy or sunny, the possible values are cloudy and sunny. So after choosing the data set, we need to split the data set into subset based upon the possible values of that particular feature. And you have to perform this operation recursively, okay, until there are no mix-up of class labels at the leaf node. Okay, when the recursion stops, we need to assign a class label. Okay, we need to assign a class label in the classification. Okay, and as well as if it is an regression, we need to we have to calculate the mean value. Okay, so these are all the things that we need to consider. Okay, and the next is like these are all the steps which is involved. Okay, and this algorithm is an ID3 algorithm that helps us to calculate the randomness or uncertainty of the data set, which is calculated using the frequency table. And how do you calculate is minus pi log to the base 2 pi, where pi it refers to the probability of an ith event. Okay, and log to the base 2, it is the contribution of the event to the entropy. So when you consider this example, at that time you'll be able to understand. Okay, so information gain is where you are supposed to calculate the difference between the entropy of the whole data set and the entropy of the individual attribute. Okay, now the decision tree example. So let us consider this is your training data set that you are going to use in order to train your model. Okay, and there is a test instance that comes like the day was rainy and it was the temperature, the humidity was high and the wind was weak. Okay, and you want to like make that algorithm, the model to automatically decide whether the person has to go out and play or not. So for these are all the steps, we have to calculate the entropy for the whole data set. And then for every feature, you need to calculate what is the entropy and the information gain. And we are supposed to pick the one that has the high information gain. So step one is we have to calculate the entropy for the whole data set. And this is the data set that we are considering, right? So how we need to calculate the formula is minus pi log to the base 2 pi. Okay, so pi refers to the probability of the occurrence of the particular event. Okay, so if you consider in this example, play is the target variable, play is the dependent variable. So you have to observe. So how many observations are there in the training data set? There are 14 observations. So out of 14 days, okay, how many yes and how many no's are there? Okay, there are 9 yes. Okay, one, if you count no, 1, 2, 3, 4, and 5. Okay, so 5 no's and 9 yes. Okay. So in that case, we have to substitute here the number of years is minus 9 by 14 log to the base 2, 9 by 14 minus 5. Okay, so 5 is how many no's? 5 days it is no. Okay, and 5 minus 5 by 14 log to the base 2, 5 by 14. And this calculation, when you do, you are getting the answer for the whole data set as 0.94. Okay. Now what we need to do is like, we need to consider the first feature. Okay. First feature in the data set is outlook. Okay. For outlook, what are all the possible values? We have sunny, we have cloudy, and we have rainy. 3 possible values are there for the outlook. So what we are going to do is like we are going to divide the data set into subsets. Okay, so for this, yeah. So we are going to divide this data set into subsets where the outlook is only sunny. Okay, you are going to extract that subset of data alone. And the second one, when the outlook is cloudy, we have 4 days. And when the outlook is rainy, there are 5 days. Okay, so what we need to do is like, we need to calculate the entropy and the information gain. Okay, for every attribute, we are going to consider the outlook first. Okay, we are going to consider the outlook first. Okay, and where entropy for this particular feature. Okay, entropy for the whole in this data set, we are going to calculate X. X is what? The first attribute, which is outlook. So what we are going to do is like, so we are going to calculate how many observations are there. So out of 14 observation, 5 days, we see that the outlook is sunny, which is 5 by 14. Okay. And how many days it is cloudy? It is 4 days it is cloudy. And how many days it is rainy? It is 5 days it is rain. So that is the reason it is 5 by 14, 4 by 14, and again 5 by 14. So in among this 5 days, you see that how many yes and how many no's are there. S is minus 2. Okay, S is minus 2 by 5 log to the base 2, 2 by 5. And how many no's are there? 3 no's are there. So therefore, minus 3 by 5 log to the base 2, 3 by 5. And when considering the outlook is cloudy, okay, 4, okay, and 4 days out of 14 days, the day is cloudy. And all the 4 days, it is yes. So we see that it is 4 by 15. And within the parenthesis, you have to give minus 4 by 4 because we see that there are the probability of no is 0. There are no other observation where the day it was cloudy. Okay, so we see that they had not gone out and played. And coming to the third subset of data, it is 5 by 14. Okay, so out of 5, how many yes and how many no? 3 yes and 2 no. So minus 3 by 5 log to the base 2, 3 by 5 minus 2 by 5 log to the base 2, 2 by 5. So on doing this calculation, when you do this calculation, mathematical computation, we are able to get the entropy for the feature outlook. Okay, so we have got the answer as 0.69. Now, based upon the entropy, we are going to calculate the information gain for the outlook, which is the entropy for the whole data set minus the entropy for the outlook. Okay, so in that case, 0.94 minus 0.69. We have got the answer as 0.2468. And similarly, like the second feature is like when the day is humidity. Okay, the next is like humidity, and humidity we see that 1, 2, 3, 4, 5, 6, 7. Okay, and out of 17 observation, 7 days the humidity is high, and the 7 days the humidity is normal. Okay, so which is 7 by 14. Okay, so minus 3 by And out of these 7, we see that 3 days it is yes and 4 days it is no. Minus 3 by 7 log to the base 2, 3 by 7, and minus 4 by 7 log to the base 2, 4 by 7. So similarly, 7 by 14, we see that how many yes? Only 1 no. Okay, and all the remaining days they had gone out and played. So which is 6 by 7, 6 minus 6 by 7 log to the base 2, 6 by 7, minus 1 by 7 log to the base 2, 1 by 7. So this value also on calculation, the answer is 0.78. Then the information gain is entropy for the whole data set minus entropy for this humidity. The answer is 0.15. So similarly, when you consider the wind as weak and strong, there are 8 days when the wind had been weak. There are 6 days when the wind had been strong. And out of the 8 days, we see that the 2 days they had not gone out and played, and 6 days they had gone out and played. So which becomes 8 divided by 40 minus 6 by 8 log to the base 2, 6 by 8 minus 2 by 8 log to the base 2, 2 by 8. So similarly, we see that there are 6 observations, and out of these 6, 3 days they had not gone out and played, and 3 days they had gone out and played. So entropy of the whole data set minus entropy for the feature wind, which is equal to, and once you subtract the difference, the value is 0.04. So you have to compare the information gain of outlook, humidity, and wind. On comparing all the 3 values, we are able to see that for outlook, the value is more, okay, when compared to any other value. Okay, so that the root node becomes the outlook. Now, based upon that, we are going to divide the data set into subset. The leftmost branch will contain all those rows where the outlook is sunny, and this will include all those branches where the outlook is cloudy. This will include all those branches where the outlook is rainy. Okay, so this process continues. Okay, so now we have to consider this as a separate subset. For this, you have to calculate the entropy for this data set, and then for outlook and humidity, and outlook and wind. Okay, so whichever is having a greater value, that becomes the next node. Okay, we see that the next is like outlook along with humidity takes a greater value, that becomes the leftmost child of the outlook. When the outlook is like cloudy, there are no mix-up of class label, and all the days they had no gone out and played. That's not a problem. Okay, but rain. Okay, so rain, and along with that, we see that the next is supposed to be the wind. Okay, wind is whether it was a strong or it was a weak. And if it is strong, how the outcome is. If it is weak, how the outcome is. So this is how we need to perform the decision tree implement. This is the theory behind the decision tree. Thank you all.